Thank you. My name is Peter Halldin. I will give you an overview of the current European cycle helmet safety testing regime, EN 1078, and what's involved in the changing of it. To start with, I would say in the discussion we just had, to me, there are no bad helmets. And I think that is a very important message to the market, that all helmets are good. They will protect your head, they will protect your brain. Rating methods can then, of course, make a judgment on better helmets. I'm from KTH, as I said, Technical University, also working for MIPS. So conflict of interest is that I'm the founder and CTO of the MIPS company. I've been working 25 years investigating oblique test methods. I will not go into details there, but working a lot trying to understand how we can mimic the real accident situation. I will give a presentation today on the current bike helmet test standard in Europe, EN 1078, and then the ongoing work towards new test standards in Europe within CEN TC 158 and the working group 11 that is called. I will introduce you to that. Talk about the need to measure the 6 degrees of freedom also in pure linear impacts, ongoing work to add oblique, angle, rotational impacts, and talk a little bit about pass-fail criteria. The question, are we ready for head FE models, and then discussion. So, to start with, within CEN, European Committee for Standardization, there is one technical committee, 158, that is called head protection. Within this committee, we have different working groups. Working group 1 is industrial helmet, 5 is equestrian helmet, 13 are helmets for mountaineers, for example. Earlier, there was a working group 4 for bike helmets, but that is not active. Working group 11 is where I'm the convener. We have since 2012 been working towards a new oblique test method that can be used within the other working groups for new standards. But as I said, there's today no active working group for bike helmets, which is a problem, but we are trying to solve that. Let's see if I can get rid of this upper, anyway, EN 1078, the current version is from 2012. There's a revision that needs to start now with changes that should be ready for 2024. And no working group, and we have no convener. But as I said, we're hopefully going to solve that during this spring. So 1078 in short, the shock absorption is a drop from 1.5 meter, 5.4 meter per second, as you probably know, impacting both flat and curbstone anvil. There are 3 impact locations separated 150 millimeters, and the pass-fail criteria is that the linear acceleration should not exceed 250 Gs, which is then a limit for skull fracture. So then there's also test for the retention system. Looking into the shock absorption test in a little bit more detail, comparing Europe and US way of doing this impact. In Europe, we use a free fall that can make the head to spin after impact, while in US they have a guided fall, so a stiff neck keeping the head in position, and we have no rotation after impact. So in the way we're doing right now, we're only measuring the linear acceleration, and what that means is that we miss the rotational part in the European way of testing. So it's more correct to do the US way like CPSC are doing with a guided fall if we're just using a linear accelerometer in the head form. So this is a problem with the current EN EN 1078. Here is just showing a typical impact of a bike helmet according to EN 1078. So you can see this rotation after impact in this impact location. In the crown impact, there are less rotation, and that's probably okay. And then we have other impacts as well. You can see also the curbstone impact, where we also see a lot of rotation that is not taken into account. And what that makes is that we miss this energy that can dissipate in rotation. And a study we did presented 2018, we can see that the rotational energy that we're not measuring can be about 15% of the total energy after impact. Then going into what we do, trying to add an angled rotational impact. And as you know, oblique impacts are more common in most sports. Oblique impacts could lead to tangential force. If the coefficient of friction is high enough, the tangential force will lead to rotation of the helmet and also the head. And we also know that the brain is more sensitive to rotation than pure translational motion, and there are a lot of studies on that topic. So what can we do then? We have the current test standards. We want to add something measuring the rotational protection in the helmet. There's a lot of proposed test methods that have been proposed during the years, but we within CEN and also most proposed standards and used in rating method is this one where we drop a head without a neck onto an angled surface. And the neck we can talk a lot about, but there's a lot of research on the neck, and the Hybrid 3 neck that is on the market today is shown to be too stiff, especially in vertical impacts. So, just looking to the ongoing work towards new sport and motorcycle helmet test standards, we have the first one that was actually presented was from FIM 2018. That is a requirement for MotoGP races to wear a helmet certified according to FIM. And also, and this standard is an angle impact similar to just dropping to a 45-degree impact angled surface. This test method was copied into EC 22.6. That is proposed as a new European motorcycle helmet test standard that will be started to use this year. There are some differences between FIM and EC 22.6 when it comes to the head form, but otherwise they're quite similar. Also within CEN, as I said, we are working towards a new test method. And there are rating programs, as we know, Sharp, Folksam, Certimo in Europe. We have Virginia Tech in US, and we have Crash in Australia. So most of these standards, proposed standards and rating method are using this test method where we drop a head form without a neck, measuring the 6 degrees of freedom over time. So I think that is the best we can do today. Of course, it would be nice to have a neck, but there are no neck on the market today that I would propose. In Australia, they are using a sliding plate that is accelerating. They drop a head form with a neck onto this head form. They are testing mainly motorcycle helmets. So why don't we have a new standard in Europe covering this? Well, we have since 2012 been working, trying to get a new standard in place. The standard should be standard measuring rotational energy in short duration impacts, and the test need to be simple, robust and cost effective, and should be based on science and real accident data. We have come to the conclusion to keep the test method that we have today, pure vertical impact but measure the 6 degrees of freedom, add an angle impact with a 45-degree impact angle, no neck. We are developing right now a new head form. That is the reason for the delay. Otherwise, I think we would have been ready 2 years ago. But it's a lot of work, especially to have a head form with the correct coefficient of friction between the helmet and the head. So the new head form will have more human-like mass, moment of inertia properties. The head shape, we're working a lot on that together with Delft University. Coefficient of friction has a lot of experiments been done at Leuven University, and we come to the conclusion to have a coefficient of friction of 0.3, and we hope to have a final head during this year. So here's just an example where we compare the new head form with a hybrid 3 head form. And this was a head form that we had ready for 2018 actually. But then we continued to work, especially with this coefficient of friction between the helmet and the head. Just to give you some information here, when you do a test comparing the hybrid 3 and this new head form with a lower coefficient of friction, that will lead probably to lower brick, star or strain in FE brain models. So that will be a result of the new head form as well. Pass-fail criteria, very important. We only have one head, so I think we should harmonize when it comes to what to measure. We can test with different impact points, velocities, etc. But the pass-fail should be based on science, and either we can use 6 degrees of freedom criteria like HIP, brick or similar, star, or we can use injury assessment tool based on computer strain from an FE model. But the question is, are we ready for an FE-based pass-fail criteria? We have some questions there actually, as we have compared 8 FE models of the human head, different models that are available in the world, simulating 17 bike helmet tests. That what Folksam study from Folksam, where they compared 17 different bike helmets from the Swedish market, 3 different impact locations, and this is all covered in. So yeah, and we missed the SUFE model in this comparison. All this is covered in this publication, ranking and rating on bicycle helmet safety performance and oblique impacts using 8 different brain injury models. It was published in March 2021, so it's a very recent publication. In the abstract, it's written, one specific helmet was rated as a 2-star when using one brain model, but as a 4-star by another model. This could cause confusion for the consumer rather than inform them of relative safety performance of a helmet. Therefore, we suggest that biomechanics community should create a norm or recommendation for future ranking and rating methods. And from the discussion, we can read, at present, depending on which model or injury metric that is chosen to evaluate helmet performance, the ranking and rating can differ. And we suggest that all rating organizations should provide clear information regarding the uncertainty in the rating depending on the metric used. So I think this is very important that anyway this information is included depending on what metric you are using. So summary. EN 1078 and other EN standards need improvements to become state-of-the-art, such as measuring the 6 degrees of freedom accelerations over time for all impacts, add an oblique impact test, new head form, and for the pass-fail criteria, we need to measure the 6 degrees of freedom over time with either criteria like brick or star, or use a metric based on a validated FE model or FE models. We can use more than one model as well. Anyway, this is not decided yet. and we hope and plan that the revised EN 1078 is ready by 2024. So that was all for me. So thank you very much.